Welcome to the session 7, module 1, and today we are going to discuss and solve problems on fluid pressure and its measurements. The objective is student will be able to distinguish between absolute, gauge pressure, vacuum pressure and atmospheric pressure. Student will be also able to define relationship between change in elevation and change in pressure. That is, intensity of pressure P is equal to specific weight of the liquid gamma L into height of the liquid HL. Student will be able to understand various types of pressure measurement instruments like manometers, mechanical and electronic type. So, these are the specific objectives for this module. As I discussed yesterday, we have simple manometer which is having one limb, in which we are going to measure the pressure measurement at a point. Simple manometer is having one limb, it will be measuring the pressure at a point, say this point. At the same time, the differential manometer which is working on the difference level between the 2 points, as I mentioned yesterday also, assume that this is a pipeline, pipe A here perpendicular to this, you are seeing the cross section here, and pipe B here. I am connecting these 2 pipes with a glass tube. I am putting a manometer liquid. I would like to know what is the difference of pressure between the pipe A and the pipeline B, right. So, that is called differential manometer. So, we are going to solve the problems today based on the pressure at a point and also the differential pressures. Is it okay? Before I continue, I would like to cover a small portion of the theory. The requirement of manometer liquids. You may be thinking, what is this manometer liquid? We use one liquid to measure the intensity of pressure at a point and also the differential pressure between the 2 points. We use one liquid, that is called manometer liquid. Manometer liquid should neither mix nor have any chemical reaction with the fluid whose pressure intensity is to be measured. It means the liquid which I am using in the glass tubes, it should be such that it should be easily distinguishable. It should not mix with the liquid which we are measuring, and it should not have any chemical reaction with that. At the same time, it should not undergo any thermal variation. Next point is, the manometer liquid should have very low vapor pressure. That is very important, which actually mercury suits to that. And at the same time, the manometer liquid which we are using in the glass tube should have pressure sensitivity. What exactly it means? For example, some people know, I am not saying in person, some people are very sensitive. By chance, if you are in a theatre or in a bus stand, you just touch them, they stare at you, they are sensitive, correct? But some people, even if they may think it's by chance, so they are not much sensitive. We need manometer liquid should have sensitive, should have pressure sensitivity. So, the moment there is a change in pressure, the moment there is a change in pressure in the pipeline or in the system, it should immediately respond to that change that is required by the manometer liquid. So, depending upon the magnitude of pressure to be measured and accuracy requirement. Sometimes we may be needing, for example, in your house, I want only line pressure. My accuracy requirement may not be much. I would like to know 1.2 bar or 0.6 bar, okay, kg per centimeter square. But sometimes if I am using a machine like a turbine or a pump, I would like to know whether the pressure is dropping to the vapor pressure level. In that case, we need very accurate level of pressure measurement, because cavitation bubbles may form. I think yesterday I discussed also cavitation bubble, they may collapse, they may damage the system. So, accuracy requirement is very high in some cases it's not much. Let us see the useful formulae which we are going to use. The most important is the hydrostatic law, which is nothing but intensity of pressure P, you can see in the cursor, gamma liquid into the H liquid. P is in Pascal or Newton per meter square. Intensity of pressure, same formula, gamma liquid is changed to rho liquid into G. What is rho liquid? Density of the liquid into G, acceleration due to gravity, the value is 9.81 multiplied by the same H liquid, that is the height of the liquid. Sometimes we represent this equation as specific gravity of the liquid into the specific weight of water, which is 9810, which is mentioned here, into height of the liquid. Is it okay? So we are going to use this concept of hydrostatic law to solve many problems today. At the same time, sometimes they may ask you the conversion from one liquid level to other liquid for the same intensity of pressure. Mind my statement, for the same intensity of pressure. Example, if I give the value of P, this P which you are seeing here in the bracket, say 100 kPa, 100 kilo Pascal, 100 into 1000 Pascal. That value I want to represent in terms of water column. Sometimes I want to represent as in terms of air column, and sometimes I want to represent in terms of mercury column. So the value will change as per the ratio of specific gravity. You can see P is equal to gamma H1 equal to gamma 2 H2. Gamma is the specific weight of the liquid 1. We can substitute by specific gravity of the liquid 1 into gamma of the water, which is 9810, into the height is equal to specific gravity of the liquid number 2 into the gamma of water into the height. So these two value will cancel, you will get S1 H1 is equal to S2 H2, which is written here. So the same intensity of pressure, the small p of say 10 kilopascal, can be measured in terms of water column, can be measured in terms of oil column, can be measured in terms of mercury column or air column. Height will be varying, right? We have discussed in the previous lecture one small problem on hydraulic jack. That is totally depending upon the Pascal's law. Today anyway we are not solving any problem on this. Px equal to Py is equal to Pz. That illustrates the pressure intensity is transmitted equal in all direction. Any particle as here, it is going to give Px, Py and Pz. All the three portions it is going to put equal pressure. Is it okay? At the same time, I would like to remind you a very important constant. One we have already discussed, the gamma of the water, which is 9810 Newton per meter cube. One more is the atmospheric pressure. We are going to use this because sometimes in the numerical they will ask you to give the answer in gauge pressure. It means I am going to measure from the gauge, but sometimes they will ask you to give in terms of absolute pressure. Then I will measure from the zero, absolute zero. Gauge pressure can be positive or negative, but absolute pressure can be never negative. It's always positive, right? So in that case, the atmospheric pressure is a very important one. You can see I have mentioned in number 4, P atmosphere is 101.3 kilopascal or 101.3 into 1000. It is also equal to 10.3 meters of water column. It is also equal to 760 mm of mercury measured by a barometer. Okay, it is at sea level. Now gamma of the air also I have mentioned 12.12. So based on this basic concept, we are going to march towards the problem. But before we continue, I would like to show you a tank, a rectangular tank in which water is there. You can see it's a atmospheric pressure here. Intensity of pressure small p is equal to 0. What exactly it means? It means it's a gauge pressure. I repeat, you can see it's a open to atmosphere, water level is shown by a small triangle, P is equal to 0, intensity of pressure is equal to 0. On the top it is atmospheric pressure, so it is a gauge pressure. You can see here in the bottom also I showed P equal to 0, same thing, atmospheric pressure at the bottom, right. Now if you see a rectangular tank and I would like to know what is the pressure here, what is the pressure here, all along the bottom. Mind my statement, if I am talking about the bottom, it means the head here is constant, the height of the liquid within the bottom is always constant, right. Here also h, here also h, here also h. It means everywhere the intensity of pressure, which is small p, is given by gamma liquid into h liquid, okay, or we can say P is equal to gamma into h, which is the specific weight of the water, which is nothing but the density multiplied by the g into h. H is the height of the liquid over which we are measuring, right. So we can see here, if you see say point A, here also head is say 10 centimeter, here also point B 10 centimeter, C 10 centimeter, same liquid, D 10 centimeter. You can see it is totally a rectangular distribution. It is totally a rectangular distribution. Everywhere the pressure is same, exactly same, right, like our UDL, uniformly distributed load, correct. Now let us see the other part of it. This we are seeing in the elevation. Let us go to the side view. Suppose if I would like to know for the same pressure what is the pressure here, then you may be thinking I am joking. We have already understood the intensity of pressure P is equal to gamma into h. I will write here. If h is 0, small p will be 0, correct. The intensity of pressure is given by hydrostatic law, specific weight of the liquid into the height of the liquid. Now let us come back to this slide. On the top you can see the h is 0, it is open to atmosphere, correct. So what will be the pressure? You are right, the value will be 0, and in the bottom it is the maximum. So P is equal to gamma h. You can see it is varying very nicely with a triangular pattern. We can say y is equal to mx pattern. Y is the intensity of pressure, x is actually the height, and gamma is a constant, which is the specific weight of the liquid. So one side in the bottom you can see it is a UDL, and other side you can see it is a triangular distribution, okay. We will come back later how to calculate all those things. Now before I start a problem, I would like to give a small hint which we will be covering in the next module. Resultant force I would like to know. Now let us take this portion as liquid top, 0 intensity pressure, maximum here. So it is a triangle which is you are showing in the diagram also. Here it is 0, here it is maximum, but you can see the width here. Can you see the width here? Here all along. I would like to know what is the total pressure on this. You may be thinking where will apply? You can apply in the overhead tank, you can apply in the oil containers. Many lorries they going, no, HP, Indian Oil Corporation, they take tankers, they are static condition that time. So I would like to know what is the total pressure on this particular face, okay. Here it is 0, here it is varying like a triangular system, okay. I would like to know what is the force acting on this based on this particular liquid pressure. So that is actually we would like to know, that we will cover in the next module, but just for your information sake we are going to work out a center of pressure. Can you see here Cp? The resultant force will be the area of this triangle into this length. What is the triangle area? It is half base into height into length, which is basically a volume. So half into gamma h, which is here, into b. B is the width of this particular, say this compass here b, okay, and h is the height. So we can exactly calculate how much pressure is coming. No doubt at the bottom maximum pressure, but what is the resultant pressure? So we need to calculate based on that. It is basically the volume prism which is available in front of you. Is it okay? We will discuss this later also. Pressure in the fluid is independent of the shape of the container. Pressure is the same at all points on a horizontal plane in a given fluid. Now let us start our problem. We will start with a very basic problem, right? Calculate intensity of pressure. Let us read the statement number problem. Calculate intensity of pressure due to a column of 0.3 meter, number 1, of water, number 2, mercury, and number 3, oil of specific gravity 0.8. It means he is asking you, this is a tank which the diagram is shown, you can see that very clearly. Tank is there and it has got a depth of 0.3 meter. Maybe you can say this is a tank and this depth is 0.3 meter. I would like to know what is the intensity of pressure if this tank is filled by water, again this tank is filled by mercury, and again the tank is filled by oil of specific gravity 0.8. Before we start, first we will take A, gamma of water as 9810, gamma of the mercury, which is the specific weight of the mercury, 13.1333416 Newton per meter cube. Then we go for oil, which is 0.8 into 9810, the value is 7848. Let us start one by one. Intensity of pressure is given by gamma L into HL, same formula, hydrostatic formula, the specific weight of the liquid into height of the liquid. So the same tank with 0.3 meter depth, it is filled with water. From here to here water is there in the tank as shown in the diagram. You can see here 0.3 meter. I would like to here. Now it is equal to gamma of the water, which is 9810, into the height, which is 0.3. Please calculate. It's the intensity of pressure measured in Pascal. Value is 2943. You can work out with your calculator, or Newton per meter square. So if you fill this with water for a depth of 0.3, the intensity of pressure is 29483. Now you will be thinking, okay sir, we will go for mercury now. The second case is the mercury, which is bit heavy. Mercury is 13.6 times heavier than water. So definitely, obviously, by common sense also, the pressure will be more. We will apply the same logic. The specific weight of mercury multiplied by 0.3. Similarly, when we go for oil, I take the specific weight of oil, which is 7848 into 0.3, which is lighter than water. Definitely pressure will be less. So 2354.54. It means we are calculating based on the height 0.3, but height is same. I am changing the liquid one by one. Once it is water, next it is mercury, and next it is oil. Is it okay? It's a small problem. Hopefully it is easy for you. Let us take one more problem. Calculate the pressure at 5 meter below the free surface of oil, whose specific gravity is 0.8. Also compute the absolute pressure at that depth. Very interesting question. In this question, he is going one step beyond. Concept is same. There is a oil tank filled up to 5 meter. It is open to atmosphere. Definitely atmospheric pressure is there. So as long as I am taking the gauge pressure, it is 0. The moment I say absolute pressure, I have to add atmospheric pressure to that. I repeat, the moment I say absolute pressure, I have to add atmospheric pressure to that point along with the gauge pressure. Let us see what is the gauge pressure. Specific gravity of the oil is 0.8, height is 5 meter. You can see here A, 5 meter, it is oil, 7848 Newton per meter cube is the specific weight of the oil. It means we are knowing this concept of gamma of the oil and height of the oil. We will apply the gauge pressure formula with PA is equal to gauge gamma of the oil into height of the oil. Same formula. We are not doing any magic as compared to the previous problem. But you can see 7848 into 5, this pressure is coming 39,240 Newton per meter square. You can check with your calculator. Now, this is not the end of the answer. He is asking you what is the absolute pressure. My dear friends, mind it well, on the top of this atmospheric pressure is there, and one atmospheric pressure is 101,325 Pascal. So, we have to add to this 39,240, we get absolute pressure at A as 140,565 Newton per meter square. Whether it is clear to you? So, this question is different from the previous question, because in the previous question they ask you the pressure intensity for gauge. This second question is being asked for absolute pressure. What is the difference between the two? Formula is same. It is gamma oil, H oil, no issue. But in this case we are adding atmospheric pressure to that, because he is interested to know the absolute pressure at A. Is it okay? So, be careful, my dear students. What is the statement of the problem? Don't be happy with gamma oil, H oil and finish. Okay? So, hopefully you understood the concept. Let us take the next question, which is again very interesting. The statement reads like this: oil with a viscosity with a specific gravity of 0.8 forms a layer of 0.9 meter deep in an open tank that is otherwise filled with water. The total depth of water and oil is 3 meter. What is the gauge pressure at the bottom of the tank? Very interesting. I will read again. Oil with a specific gravity of 0.8 forms a layer of 0.9 meter deep in an open tank that is otherwise filled with water. The total depth of water and oil is 3 meter. What is the gauge pressure at the bottom of the tank? Okay, my dear friends, you can see it's a small tank having two layers of liquid. One layer is oil above this and other is water. So, definitely we have to apply at different levels of the pressure, and he is asking you to calculate gauge pressure. He is asking you to calculate gauge pressure. Okay. Now, the moment I say gauge pressure, I go to the top of the tank which is open to atmosphere. The moment I say it is open to atmosphere, the gauge pressure at the point 1, which you can see in the diagram, it is mentioned. It is P1 equal to 0, as it is a gauge pressure. Then you may be thinking, okay sir, suppose if it is absolute pressure, then the P1 will be 101,325 Pascal, as we did in the last problem. Okay. Let us take step 2. Step 1 on the top. Step 2, I need to go down. It is a oil. I am going in the downward direction. It is going to be positive. I will go back to the board now. You can see here, any pressure which is going down is going to be considered as positive. We say specific weight of the water into specific gravity of the liquid into the height of the liquid. So, if I am moving downwards, it is positive. It is a increase in pressure. It is a increase in pressure, right. Let us come back to the slide. Now, let us see from here 1 1 to 2 2, I am going in the downward direction. So, at the level 2, which is the interface between water and oil, definitely water is heavy, it is down, oil is lighter, it is on the top, correct. So, at the 2 point, I will be having P2 is equal to P1, which is the intensity of pressure at 1, plus H oil, which is this oil, into specific gravity of the oil into gamma W. The formula which I have written on the board, same thing. H oil, specific gravity of the oil, gamma of the oil. Let us see what are these values. Height of the oil portion is 0.9 meter is mentioned. Specific gravity of the oil is given as 0.8 in the statement. I take 0.8. Gamma W, specific weight of the water, which is 9810, always 9810. Multiply that, you can see this P1 is 0, 0 plus this value 706 Pascal. So, pressure will be varying like this. It will come like this, right? Now let us go to the bottom. He is not asking you to calculate at the interface. He is asking you what is the gauge pressure at the bottom of the tank. Where is the bottom? Here. Bottom of the tank is represented by number 3. Bottom of the tank is represented by number 3. P3 is equal to definitely P2 plus height of the water. Same thing, we are going from 2 to 3 in which direction? Downward direction. So we will take positive. Next, height of the water, total is 3 meter, 0.9 if you subtract you get 2.1 meter, 2.1 into specific gravity of the water into gamma L. So it is going to be 27,700 Pascal. Okay. Let us take one more problem on the same line. A 6 meter tank contains 4 meter of water and 2 meter of oil of relative density 0.88. Don't get scared. Relative density is nothing but specific gravity. Relative means we are comparing. So relative density means specific gravity. Find the total hydrostatic force acting on one side of the tank per meter width. So he is asking you what is the force, pressure on the one side. We go on the same line. On the top one you can see in the tank is atmosphere. P1 will be 0 as mentioned here 0. P2 will be oil pressure, gamma oil H oil, gamma of the oil 0.88 into 9810 into height which is 2 meter which is mentioned here. So you get the pressure here, and P3 at the bottom of the tank which is nothing but P2 plus specific gravity of the water 1 into 9810 into 4 meter, you get this value and you total it. So this is the pressure which we are getting here. Okay. So we are calculating the pressure on this. Let us take the next question. It is a very interesting problem. In this case, an underground gasoline tank is accidentally opened during raining, causing the water to seep in and occupy the bottom part of the tank as shown in the figure. It means there is a gasoline or say petrol, and by mistake that bunker was open. So raindrops will come and they will occupy the bottom position. Okay, because rain is heavier, water is heavier compared to gasoline. Calculate the gauge pressure at the interface of the gasoline and water at the bottom of the tank. At the same time, he is asking you express the pressure in Pascal, express the pressure in meters of head of water, use gamma water as 9810. So mind it well my friend, this question, a gasoline tank which is open to atmosphere by mistake, water is entering at the bottom of the tank to an extent of 1 meter depth, you can see in the slide, and you can see the gasoline is filled up to 5.5. So he is asking you to calculate the intensity of pressure at different levels. Is it okay? Now you can see here what is given to you. First, the gasoline value is given. We can work out the specific weight based on the specific gravity of the gasoline, which is 0.65 into 9810. The value will come as 6376.5. Now in this case we know very well the pressure here is 0. The moment I come down, I have mentioned here, you can see top pressure calculation, bottom. If you go about downside, it is positive. What is that equation? You know very well, the equation is gamma H, gamma gasoline H gasoline plus gamma water H water. Simple. Let us see one by one. If you see in the this one, the P1, you can say we are going to add P0 plus gamma gasoline into H. Initially on the top of the gasoline portion it is 0, open to atmosphere, it is a gauge pressure. We are going to have 0 there, plus gamma gasoline is 6376.5 as we have calculated on the top near given, into the height you can see in the gasoline tank is 5.5. So, we take 6376.5 which is the specific weight of the gasoline into the height 5.5. This is the pressure at 1, it means at this interface, okay. Now, next level is here, we have to add P2, you can see here P2, P1 plus gamma of water into H of water. Here P1 is 350.70.75 plus gamma of the water 9810 into the height of the water is 1, specific gravity of water is 1. So, if you calculate you get this. But main thing is it is not much different from the previous problem. We have taken the gasoline top, it is 0. We have gone to the gasoline level 1, gamma gasoline into, you can see here gamma gasoline into H gasoline, we got the answer. Similarly, we have gone to P2 at this point, the value is P1 plus gamma water into H water. We have added this value 350.70 is added here plus 9810 into 1. So, we get the answer P2 as the final pressure on the bottom. But you can see here, if you go back to the statement of the problem, express the pressure in Pascal, which we have already done. What is the Pascal? Newton per meter square, which we have already got. But he is asking you one more thing, the meters of head of water. So, if you see the answer, we have taken H water, is equal to P1 by gamma W, which is 3.575 meter for water. For P2 also you can see the intensity of pressure is 44,880, which is mentioned here, divided by gamma W, which is the specific weight of the water, we get 4.575. So, this question is adding one more system into problem. What is that? We are able to express the answer in terms of water head. We have divided the intensity of pressure P1, which is here, divided by gamma W, and here also P2 by gamma W. P1 by gamma W gave the answer 3.575 and P2 by gamma W has given the answer 4.575. So, this question has added one more angle as compared to the previous one. Previous one we have added the absolute pressure concept. Okay? Previous one was straightforward. Now, we have added, we can express the answer in terms of water head. Is it okay? Let us take next problem. Okay. This is a very simple problem. You can see, determine the gauge and absolute pressure at A for the manometer shown in the figure. It is a simple manometer. Given the specific gravity of manometer liquid is 1.65 and atmospheric pressure is 101,403. Is it okay? Now, this question, if you see the diagram, this is a manometer exactly like a pipe perpendicular to this. This is the point A, this is the point A. This point is connected to a tube exactly like what is shown as a simple manometer of a specific gravity 1.65. Height of the manometer liquid is 75 centimeter. I always told you, my dear friends, remember any unit which is given in mm divide by 1000. Any unit which is given in centimeter you divide by 100. Is it okay? Let us see how to solve this problem. Concept is same. We are going to start our point from the point A. Let us see how we write. PA is the intensity of pressure at A. PA. From this point, I am travelling same pressure up to this point. There is no variation of water head level. From this point to this point, inside the tube, same liquid, same level. So, we can say the intensity of pressure at A and intensity of pressure at 1 is same. Correct? I repeat, the intensity of pressure at A, which is here, and same level at the point 1 here, which is put at a dot. You can see same pressure I have mentioned by arrow also. Can you see that? It is same. Now my question is, from here how you are going? Are you going downward? Your answer is no. Correct. We are going upwards. The moment I say I am going upward, I am going to put a negative value. It is going to decrease. So you can see here in the board also, if I am putting up any point, it is going to be negative. It is going to be gamma of the water, specific gravity of the manometer liquid into height of the manometer liquid. But if I go up, it is minus. If I go down, it is positive. So always remember this concept. If you remember this concept, you can solve any problem. Let us come back to the problem. So we started our journey from the point A. We travelled at the same level, same pressure as intensity of pressure A, but my dear friends, from here we are marching upwards. If I am marching upwards, I am going to take the value as negative. So I put negative specific gravity of the manometer liquid, you can see that in the equation, into the height of the manometer liquid. What is specific gravity? It is 1.65. What is the height? You can see it is 75 centimeter converted to meter in the slide by dividing by 100 as 0.75. Is it okay? So if you see that equation, it is nothing but Pa is equal to Sm into Hm into gamma W, which is nothing but 1.65 into 0.75 into 9810. If you solve that by your calculator, the intensity of pressure at the point is 12,139.9 Newton per meter square. That value is obtaining. But this value which we have obtained by the concept A to A and upwards minus is a gauge pressure. I am equating it to 0. Can you see the first equation here? It is very clearly mentioned, Pa minus Sm into Hm into gamma W upwards is equal to 0. That is a gauge pressure. Suppose if I want to convert this gauge pressure to absolute pressure, in that case what I will do? I am going to add the atmospheric pressure to that. So how much is the atmospheric pressure? You can see in the statement of the question, it is written here 101,403. So I say Pa is equal to 101,403 plus this value 12,139.9. If I add, I will get the absolute pressure at A. So this question illustrates you the concept. Pa remains the same at the same level. When you go up, it is going to be negative. The moment you reach the atmospheric pressure, it is going to be 0. Is it okay? So let us go to the next concept. I think this is the minus concept. Let us take this problem. Pressure gauge B is to measure the pressure at the point A in water flow if the pressure at B is 87 kPa, 87 kilopascal. Estimate the pressure at A in kPa given fluids are at 20 degrees centigrade. Specific gravity, they have used a oil called SAE 30 oil as 0.7. Now main thing is, let us go to the diagram. You can see there is a pipeline exactly like this. I am connecting it to a manometer system which is given here. Okay. Now the point A, which is the actually pipeline here, you can see here the point A, from there I am coming down, right, number 1 by 5 centimeter. Can you see the diagram very carefully? You can see very clearly it is coming down by 5 centimeter, again it is down up to 4 centimeter, but at the same level, same liquid, we can transfer the other side, and it is going up by mercury and up by group gauge B. So if you see that particular equation, we are going to start from the point A, which is point A here. We are going to add by 5 centimeter down, which is height of the water as 5 centimeter. Specific gravity of water is 1, but you may be thinking sir 5 centimeter is there, we have to divide by 100. You can see in the equation I have divided by 100 here, okay, into specific gravity of water 1, right, into 9810, then minus, because if you go here it is minus here, so minus h of the oil, h of the mercury, height of the mercury is 7 centimeter, then we write specific gravity 13.6 into 9810, then we go further by minus 6 centimeter with a group B oil which is actually 0.7, so again 0.7 into height, you can see here in the cursor 6 centimeter by 100 into gamma of the water. So definitely in this case we are travelling the point A, here positive, same liquid, same level, minus and minus. So we have 2 minus upwards and 1 positive downwards. This is 5 centimeter converted to meter. This is actually remaining is 11 minus 4, 7 converted by divided by 100, right, and here 6 centimeter of the oil which is here 6 centimeter of the oil divided by 100 into 0.7 which is the specific gravity of the 0.7. So definitely this question also gives an idea how to calculate the pressure at A based on the value which is given at pressure at B. The pressure at B is given as 87 kPa. You can see 87 into 1000 I have multiplied, I have equated it to it. So it is a gauge pressure only, no doubt. We are starting from this point and reaching this point. While travelling we go down by 5 centimeter, gamma W into specific gravity, here same level 11 minus 4, 7 centimeter upwards, mercury 13.6 into 9810 into 7 centimeter by 100. Here it is a oil again going upwards with a minus sign 6 centimeter, we can see here, into specific gravity of the oil 0.7 into 9810 equated to a known value at gauge B. The value is 87 into 1000. So if you solve that you get a value of 96.2655 kilopascal. Whatever value has come I have divided by 1000. So this question also gives you a nice representation how we apply S1H1 minus S2H2 concept to calculate the pressure. Let us take a totally different problem. It is an inclined manometer. You can see it is a differential inclined manometer. Let us read the statement. Determine the pressure difference delta P between the pipeline A and the B. Given specific gravity of manometer is 13.6. Okay, let us study the system before we go to equation. The point A is here, we say PA. Point A is here, pressure here is PA. Point B is here, we say pressure B. We reach at the end. Now we start our journey from the left. Mind it well, we need only vertical distance. First one, no issue at all. Specific gravity 1 with a 0.9 for a height of 100 mm. So when I apply to equation, I will divide by 1000. You can see H1. What is your S1? S1 is 0.9. So when I start from PA, you are knowing you are going downwards. So PA plus S1 H1 into gamma W, I have put a downward arrow also. Is it okay? Now come to this level. This level you are seeing that it is going to be again downwards till we reach here 50 sin 30. As I mentioned earlier also, whatever distance we are measuring along the inclined manometer, we are going to calculate the vertical distance only. So if you have vertical distance 50 mm, this is sin theta. So 50 mm into sin theta, sin 30, it will be 25 mm, no doubt. So we are going to calculate 25 mm. S2 is specific gravity 13.6. So I say plus S2 13.6 into gamma W into the height, which is 50 sin 30, which is nothing but 25 mm. Okay? Okay. So you understood that we have come from A point to this point by downward journey. From this point to this level, mark is there, no? Again downward journey with a specific gravity of 13.6. Now my dear friends, we are going upwards from this side. I repeat, from this point we are going upwards. So what will be the equation? Definitely the equation will be negative. I have mentioned negative. Minus S3, which is this one, into H3, which is 80 mm, into gamma W, which is the specific weight of water. If I do that, I reach the point B, I say it is equated to PB. Suppose if it is open to atmosphere, I will put it 0, but it is not open. So we started from PA, we started journey S1, H1, gamma W, we again gone down S2, H2 sin theta gamma W. From here we are going upwards, so minus S3, H3 gamma W. Is it okay? And it is equated to pressure at the point B. Substitute all the values, my dear friends. Those who are having calculator, you can work out and you can see a surprising PAB is coming negative. What does it mean? It says that the pressure at the point B is more than A, which is obvious, my dear friends. Manometer liquid is pressed more here and manometer liquid is pressed less here. Definitely the intensity of pressure at B is more as compared to A. That is the reason when we take PA minus PB, it is giving a negative value. Is it okay? So this is a inclined manometer problem which we have solved now. Let us take one more problem. Again it is the same problem. The manometer shown in the figure contains 3 liquids, but in this case, earlier cases you remember PA used to calculate it. This time I am giving you P1. At the point 1, pressure 1 is known as 10 Pascal. Okay, when I write the P1 value is 10, you can see in the cursor also. Okay, and let us start our journey of manometer. From here to here we are going downwards, it is a positive. Height of the liquid 40 mm, it is going to be the specific gravity here into the gamma W. From here to here I am going again downwards with a oil of specific gravity 0.88, height is 50 mm. So again positive, H of oil into specific gravity of the oil into gamma W. Okay, from here to here again I am going downwards. So again it is positive from this point to this point. So specific gravity of water into 30 mm into gamma W. From this point it is going to be minus. The moment I see here it is minus. What is the height? It is D. What is the liquid? It is the mercury into gamma of water. So that again we reach here, you can see the height is 70 mm, this height is 70 mm, the specific gravity of this liquid is given and into we are going to get gamma water. So concept is same, we are going to apply the same equation for all. Starting from the top, the moment you come down, it is 10 Pascal plus height of the water into 9810 into 1 plus 50 divided by 1000 into 0.88, like that we go on doing it, and ultimately we get the answer as D value as 78.24. Is it okay? Let us take this problem. This problem on manometer, same concept. We have given find the pressure head at the point B in terms of water head. It is a water head, P by gamma W, we need to convert this head always. So starting from this point 60 kPa, we can see 60 into 1000 divided by 9810, same concept, yellow line, you can see 60 into 1000 pressure into 1000 divided by 9810, 6.116. Starting from this point, same value. From here we are going upwards, from here we are going downwards, correct. So this level and this level is same for the same liquid, same pressure will be maintained as 60, and here you are coming downwards with a height of 3, and we say S1 H1, we say S1 H1 gamma W, gamma W is divided, so S1 H1 plus S2 H2, and we reach the point B. Is it okay? Same concept is applied for this case also. Hopefully it is clear to you. I will skip this question. Let us go to the last problem. A vertical cylinder 300 mm in diameter is fitted at the top with a tight but frictionless piston and filled with water at 70 degrees centigrade. The outer portion of the piston is exposed to atmospheric pressure, which is 101.3 kPa. Calculate the minimum force applied on the piston that will cause the water to boil at 70 degrees centigrade. Okay, the vapor pressure of the water is given as 32 kPa. Let us see this equation. This is the piston, you can see, and D value is given as 300 mm. We can calculate the area, pi by 4 d square. Question is very simple. Outside atmospheric pressure is 101.3, inside is minus 32 for vapor pressure. Calculate the delta P, which is the force change in pressure divided by area. So, force can be calculated based on the change of pressure. The change of pressure is nothing but the atmospheric pressure minus vapor pressure of the liquid and multiplied by the area of the piston, which is given here as pi by 4 d square. If you calculate, you get the force as 4898.6. So, my dear friends, what the journey for module 1 is completing here today. We have covered starting from the basic properties of the liquids to the measurement of the pressure by manometer, by gauges, by transducers, and we have done the numerical on hydrostatic and manometric concept and vapor pressure also. So, thank you very much. See you once again in the next session.